Hey everyone, Mr. Voikin here, and we're moving on to lesson 3 in unit 7, and we'll start off with a little bit of review. So we want to know what makes a relation. Well, it's a connection between two quantities, so two different things, so height and time, something like that. A relation can be represented graphically by a set of ordered pairs. Okay, and the first set of the ordered pairs, which looks like this, is our x, and the second one is our y. Now we say that the x is the input and the y is the output, and the values on the input are known as the independent variable, and the ones on the y are the dependent variable. Okay, so let's take a look at these three graphs that they give us right here. So the first one is a linear equation, and if we follow in example A, it's saying what are the coordinates of the where it crosses the x-axis. So that's that point, that point, that point, this point, and that point on all three graphs. So on graph 1, we can see that the x value is going to be -3 and the y is 0. On graph 2, we can see that the x value is -2 and 0 and 3 and 0. And on the third graph, it's going to be -4, 0, and 4 and 0. Crosses in two places, and it says, what do all the points have in common in section A? Well, when we're determining where the graph crosses the x-axis, every time y will equal 0. So that makes sense that if we're determining in part C here, where it crosses the y-axis, what do all points have in common? Well, where it crosses the y-axis, x will equal 0. So if we look at graph number 1, 2, and 3, those should all be zeros. And on graph 1, it crosses at 5. On graph 2, it looks somewhere around 6. And on graph 3, it looks like it's going to be -4 and a +4. Okay, so that should be fairly simple to understand. So the x-intercept, y-intercept. Okay, so they're just sort of reinforcing this right here. To determine the x-intercept, we just make y at 0. And to determine the y-intercept, we just set x to 0. So let's go take a look at this class example 1. So it says we have this equation, which is 3y equals 5x plus 15. And on the left, we want to solve the x-intercept, and on the right, the y-intercept. So again, what do we know about the y-intercept? Well, or the x-intercept, y equals 0. And what do we know about the y-intercept? That is where x equals 0. So all I do is substitute, to solve for the x-intercept, I just substitute the y with 0. So this becomes 3 times 0 equals 5x plus 15, which is going to be 0 equals 5x plus 15. Simple algebraic solution here. We're just going to subtract 15 from both sides, and I end up with -15 equals 5x, and I'm going to divide by 5 on both sides, and I end up with x equaling -3. Okay, and for the y-intercept, we're just going to substitute x with 0, so 3y equals 5 times 0 plus 15, so 3y equals 15, and divide by 3 on both sides, and we get y equals 5. Okay, so the x-intercept for this equation right here is going to be -3, and the y-intercept is going to be at 5. Okay, so class example 2 is basically the same thing, just different equations. So we've got x squared plus y squared equals 16, x squared plus y squared equals 16. And they're saying this is from the third graph. So that's up here, this one. And you can see we should have a positive and negative x-intercept and a positive and negative y-intercept. Okay, so at the x-intercept, what do we know? We know that y equals 0. And at the y-intercept, what do we know? X equals 0. So I'm just going to substitute. So let's go back to the first one. X squared plus 0 squared equals 16. So basically x squared equals 16. And I'm going to take the square root of both sides, and that leaves me with x equals. Now, remember, if we take the square root of a positive number, that could be a positive result or a negative result. So for example, -4 times -4 is 16, and 4 times 4 is 16. And another way to write this is x equals plus minus 4. So on the y-intercept, we're going to replace x with 0, and that's going to give us y squared equals 16. Take the square root of both sides, and I get y equals positive or negative 4. Okay, fairly simple. And class example number 3. So we have a word problem here and a whole bunch of a table to fill in and a graph to fill in and some questions to answer. So let's first of all start with the question and sort of break it down. So Lisa purchases a new car for $20,000. So when she buys it on day one, it's $20,000, which is sort of before she buys it, it's worth $20,000. Okay, the value of the car can be represented by the formula V, which is the value of the car, equals 20,000, which is our original purchase, minus 1,250 times T, and T is the number of years. So basically, if we look at this table, it's saying, let's take our inputs, which are going to be right down here, and let's put them into this formula right here. Okay, so if I replace T, which is our input, with 0, that's going to sort of kill that, and we're going to end up with 20,000 minus 0, which is going to be 20,000. So this is 20,000. Our ordered pair is going to be 0 and 20,000. Now on year 2, it's going to be 20,000 minus 1,250 times T, which is 2, which is going to be 2,500. So it's going to be 20,000 minus 2,500, which is going to be 17,500. So in here, our ordered pair is 2 and 17,500. Now, as long as we've got a constant change here, so it's plus 2, plus 2, plus 2, in a linear equation, the output will also change by whatever it's changing. So each time it's going down by 2,500, so this should now be 15,000, and this should be 12,500, giving us the ordered pairs like that, and 6, 12,500. Okay, and if we're to graph this, we're going to start off at 0, which is right on the y-axis, and at 20,000. So that's going to be right up at the top here. And I don't need to make it quite that big. And then at 2, so I need to sort of take a look at my graph. 2 is going to be right here, 1, 2 over. It's going to be 17,500. So that's going to be right here. And in the 4th year, it's going to be 15,000. And in the 6th year, it's going to be 12,500. And if we take a line and run it down, it should go through all those points and essentially go down like that. Okay. Now, if we follow that down, and as long as we've plotted it accurately, we should almost be able to hopefully guess at what point will the car be worth 0. In this case, it's saying at 16 years. So right down here, it's going to equal 0. Okay, so let's take a look at part B. What does the ordered pair 0, 20,000 represent? This is the original purchase price, which is going to be our y-intercept. Okay, use the graph to estimate the t-intercept, which t is our x. So we already did that. It should be around 16. So t should equal 16. The t-intercept should equal 16. Okay, which is going to have the ordered pair of 16x and 0y. Okay, part D says use the graph to estimate the value of the car after 3 years. So all we're going to do is we're going to take a line straight off of the 3 going up, and we're going to see where that crosses, and then we're going to take that over this direction, which is going to give us about 16,000. So it should be worth $16,000 after 3 years. And after 10 years, we're going to do the same thing. So we're going to go up from the 10, see where that crosses, and then go over from that point. And we can see that that is going to be 7,500. And at 14 years, it's going to go up to this point right here, and then over to this point right here, which is going to be 2,500. And it says use the formula to verify D. Okay, so we'll just do one of them. We'll do the 10 years. So we're going to take the original formula, which is V equals 20,000 minus 1,250 times T. And if we look at 10, that's the number of years, that's on the x-axis. So this down here is the number of years, and this is right here the value on the y-axis. So essentially what I'm going to do is just the value is going to be 20,000 minus the 1250 times 10, which is going to be minus 12,500. So there the value should be 7,500. And we are correct, sir. Okay, and part F. Use the graph to estimate when the car will be worth 5,000. Well, it's the same thing we were doing before. We're just going to slide sort of over the other direction. So 5,000 is going to come over this way, and wherever it hits the graph, I'm just going to make the line a little bit thicker so you can see it. So we're going to come over. Wherever it hits the graph, we're then going to go straight down. And you can see that that's going to be about 12 years. and half the purchase price. So the original purchase price was 20,000, so half the purchase price would be 10,000. So we go from 10,000 over to our line, and then from our line down to the x-axis, and that tells us that it is going to be 8 years. And again, they want to take our original formula, which is V equals 20,000 minus 1250t, and we want to verify the answers that we got in part F using our graph. So this 8 right here is what we're trying to verify, and the value at this point was 10,000. That's half the purchase price. So I'm just going to substitute the V for 10,000, and that equals 20,000 minus 1250 t. I'm going to subtract 20,000 from both sides, and I end up with negative 10,000 equals negative 1,250 t. So I'm going to divide by negative 1,250 on both sides, and I'm going to get t is equal to, and hopefully that's going to be 8. We'll punch that in the calculator just to verify. So negative 10,000 divided by negative 1250 gives us 8. So completely verified. That's good. Now let's go down to H. Complete the following statement to describe the relation. The original value of the car is $20,000. Don't forget the units. It depreciated by a value of $1,250 per year and has no value after 16 years. So there we go. What does it say here? We'll just read this really quickly before we move you on to the assignment. So it gives us a big note. This guy's stopping us right here, and he's saying, in this lesson, using algebra determines the exact value for intercepts, etc., whereas using graphs gives an estimate for the intercepts. So it may look like it's going through those points, but the only way to really verify that is to use algebra and or the functions on your calculator that would print out a table that you could take a look at. Okay. So in part D, we were asked to use the graph to find values lying between the given points. This process is called interpolation. Extending the graph to predict values outside of the plotted points is called extrapolation. Okay, so if you look at it, it says in part D, we were asked to use the graph to find values lying between the points. That's inside the points. That's interpolation. And outside of our points would be extrapolation. Okay, so if we were asked to solve a point right here, that's going to be extrapolation. And if we were asked to select a point right here, that'd be interpolation, if I spelled that correctly. Okay, so looks like the assignment starts on page 416 right here and goes all the way through to page 421, and the answers are on 422. So get on it and enjoy.